Welcome back to B Spice. In this session, we'll continue with instrumentation question and answer, part 6, wherein we'll focus on differential pressure transmitter. And before proceeding, one item I want to clarify. See, whatever we have covered in earlier, like the pressure transmitter. So I'm not going to repeat that. Okay. So those aspects are common to differential pressure transmitter also. Only which is pertinent to this differential pressure transmitter, I'm going to cover here. So let us see the principle. Okay. A differential pressure transmitter is an instrument, right? That measures the difference in pressure between 2 points, high pressure and low pressure, right, friends? So that's it. It used in industrial process control system for various measurement like flow, level, pressure, all these. Okay. So the differential pressure transmitter typically uses a sensing element. Okay, here. Okay. So like a diaphragm that fluxes or moves in response to a pressure difference. So this movement is converted to an electrical signal proportional to the difference, pressure difference, which can then process and displayed as a reading for us. So this is just a common, understanding. So now let us move into the specifics related interview question related to differential. See, what are all the common application of pressure and differential pressure? Differential pressure are used in variety of application, including, flow measurement in pipe, by creating a pressure drop either with an orifice plate, venturi tube, all these actually. In fact, we have uploaded many videos on this, many videos on this. If you are really interested, you can, subscribe and you can, watch. Really interested. Okay. Then, of course, the level measurement in tanks, all these, and also, like filter monitoring by measuring the pressure drop across the filter. So these are some of the common application of differential pressure meter. Okay. So the range of pressure that differential pressure can measure. The range of pressure that differential pressure transmitter can measure. So what are all the range? See, basically the pressure range that a differential pressure transmitter can measure depends on, the specific model and design. But it varies from, very low differential pressure, like, few millibars or inches of water, to a high differential pressure, hundreds of bars of PSI. So it varies actually, right? So for that particular application, we need to, select. Okay. In fact, those things also we have covered in detail, actually, in detail. Many videos on this. If you want, you can, watch and get benefited if you are interested. Okay. Then, can differential pressure transmitter can be used to measure absolute pressure? So this is a different typical question actually. Can a differential pressure transmitter can be used to measure absolute pressure? A differential pressure transmitter measures the difference in pressure between 2 points, right? And cannot measure absolute pressure directly, right, friends? So there are a pressure transmitter, which, the pressure transmitter, what we have covered last time, so that you can use it. But here, differential pressure cannot measure the absolute pressure directly. However, if one of the point is a known reference pressure, like, vacuum, then the absolute pressure at the other point can be determined. So the point to note is it cannot measure absolute pressure directly. However, if one of the point is a known reference pressure, then the absolute pressure at the other point can be determined. So that is how we need to, but the straight automatic choice is pressure transmitter. Okay, right, not the differential one. Okay, impact of the changes in process temperature on output signal of a differential pressure transmitter. So what are all the impact of these changes? Process temperature. Definitely, right? Yes. Changes in process temperature can cause thermal expansion or contraction of the sensing element, other components, which can affect the output signal, right, friends? So change in the pressure temperature can cause thermal expansion. So the answer is yes. So the temperature changes impacts the output signal. So what is that impact? Can cause thermal expansion or contraction of sensing element. Thereby, it can affect the output signal. So nowadays, most differential pressure transmitter include temperature compensation to minimize this effect. Okay, that is the point. Okay, so another question. Differential pressure transmitter measure flow rate, right? Yes. So the question here is, yes, a differential pressure transmitter can be used to measure flow rate. How? By measuring the pressure drop across the restriction. So what is that? Orifice plate, venturi, flow nozzle. There are many measurements. Okay, that is the point. So the answer is, yeah, measure flow rate. So how? By measuring the pressure drop across the restriction. That's it. So the flow rate can be calculated from the pressure drop using Bernoulli's equation. So that's the point. And of course, the properties of the fluid. Right, friends? So I hope you understand this. Okay, let us move into the different, this one. Okay, what are all the, factors that affect the selection of the differential pressure transmitter? Basically, what are all the factors that can affect the, selection of pressure differential pressure transmitter? Okay, for example, you are selecting a DP. So there should be some, factors you should focus also, right? Yes. So the factors affecting the selection of differential pressure transmitter include pressure range, accuracy, fluid type, properties, of course, the process temperature and pressure, and of course, the process connection and specific features like digital communication or intrinsic safety. These are the focus, factors we should focus on. Okay, that will impact the selection of differential pressure transmitter. Then another question actually, can a differential pressure transmitter measure the vacuum? The answer is yes. A differential pressure transmitter can measure vacuum, which is a pressure lower than atmospheric pressure. What is it, vacuum? It is a pressure lower than atmospheric pressure. So the transmitter is typically calibrated with low pressure port, LP side, open to atmosphere, and the vacuum is applied to the high pressure port. So that is the point. Okay, friends? Like for example, you can consider here, see this one, low pressure port here, right? This guy will open to atmosphere and here high side apply to the high pressure port. Okay, that's it. So then again, seal pot or chemical seal in a differential pressure transmitter. So what is the seal pot or chemical seal? Yes, a seal pot or chemical seal is a device used with the pressure differential transmitter to isolate the transmitter from process fluid. That is the pointer. So basically it is filled with sealing fluid that transmit the pressure without allowing the process fluid to contact the transmitter. That is the point actually. In fact, we have covered this many videos actually in detail. Those who are not, subscribed and those who are not, seen, you can watch and get benefited. This is detailed out in the detail engineering aspects. Of course, it was, qualified or marked as a member video. If you are interested in become a member and watch. Okay, that's it. Of course, I am not compelling you. It's free, up to you. Okay. Yes, the point is seal pot or chemical seal in a differential pressure transmitter. So basically, this is a device used in a differential pressure transmitter to isolate the transmitter from the process fluid. That is the point. So basically, the seal pot is filled with a sealing fluid that transmit the pressure without allowing the process fluid to contact the transmitter. So that is the point. Okay, then can differential pressure transmitter, okay, differential pressure transmitter usage in high temperature fluids. Okay, so how? Yes, a differential pressure transmitter can be used with high temperature fluids, but provided the temperature is within the transmitter specified limits. So a seal pot or cooling element may be used to protect the transmitter from excessive temperature. Same concept, what we have discussed earlier. Okay, so that is the point here. Okay, then compensated differential pressure transmitter. What is this compensated differential pressure transmitter? Any guess? Compensated pressure differential pressure transmitter. A compensated differential pressure transmitter is a transmitter that includes compensation for factors that can affect the measurement, such as temperature, static pressure, meaning the high pressure, or non-linearities of the sensing element. So the compensation can improve the accuracy and stability of the transmitter. So that is the point. Okay. So that's all for this and few more to add on. Turn down ratio or rangeability in a differential pressure transmitter. What is that? See, basically the turn down ratio, the rangeability of a pressure transmitter, differential pressure transmitter is a ratio of the maximum pressure, okay, to the minimum pressure it can measure accurately. That is a point. So ratio of the maximum pressure it can measure to the minimum pressure it can measure accurately. That's it. So a higher turn down ratio allows the transmitter to accurately measure the wider range of pressure. Obvious, isn't it? Yes. So that is the turn down ratio rangeability. Then differential pressure transmitter usage in a vacuum service. Differential pressure transmitter usage in vacuum services. Yes, we can use it. So can be used in vacuum service by calibrating with the low pressure side open to atmosphere and vacuum applied to the high pressure side. Same as what we discussed earlier. Okay, that's it. Then what is the effect of altitude or atmospheric pressure on the differential pressure transmitter? The effect of altitude, meaning the height, right? Yes. So the effect of altitude or atmospheric pressure on a differential pressure transmitter is typically small because the transmitter measures the difference in pressure between 2 points, right? Yes. However, if one of the pressure port is open to atmosphere, the transmitter will measure the pressure relative to atmospheric pressure, which can vary with altitude or weather conditions. Basically, the effect of altitude or atmospheric pressure on a differential pressure transmitter is very small. Okay, because it measures the difference between 2 points, right? That is a point. Okay, right. Then gauge pressure. We are talking about gauge pressure and all, right? So what's the difference between gauge pressure and differential pressure? Gauge pressure is the pressure relative to atmospheric pressure, which we have discussed on the pressure transmitter. And differential pressure is the difference between 2 points. That's it. Yeah, differential pressure transmitter can measure gauge pressure if one of the pressure port is open to atmosphere. You got it? Good to go. Right. So differential pressure transmitter in steam service. That is also very, very important actually. So yes. So any guess? Can we use this steam service? So what sort of precautions we should take care? We should take note or something. Differential pressure transmitter in a steam service. Yes, we can use it. Of course, we need to take care of, all the, what do you call, um, the steam, temperature rating, all these we should focus. And also, the diaphragm seal, what you are, selecting that should actually withstand. All these we should focus. Okay, friends? Right. So what else? There are a few more to add on actually. Just a moment. Yeah. So here, one point actually, I want to tell you, of course, we can do this steam service, but when we install this differential pressure transmitter in a steam service, precaution should be taken, as I highlighted earlier, to protect the transmitter from excessive temperature, condensate, and pressure surges. So again, we can use, seal pot or cooling element or impulse line and ensuring the transmitter is rated for that service. So that is the point. Right, good to go. Then differential pressure transmitter for static pressure. Can a differential pressure transmitter measure static pressure? A differential pressure transmitter can measure static pressure. Static pressure is nothing but the highest pressure applied to one side. Okay. So if one of the pressure port is connected to the process, and other port is open to atmosphere or connected to a pressure reference. Okay. However, a static pressure transmitter or a gauge pressure transmitter is typically used for this purpose. That is the point. We don't have to use differential pressure transmitter. That's the point. Okay. So then what is the impact of the process fluid viscosity on differential pressure transmitter? This is also another important aspect. Impact of process fluid. Yes. So that is actually, it what do you call it affects in fact. So the viscosity of the process fluid can affect the measurement of a differential pressure transmitter by causing non-linearities or delay in the pressure transmission. So yes, pressure transmission, right? So especially if the pressure ports or impulse line are small or long. High viscosity fluids can also cause clogging or require special seals or fittings. So that is why, friends, if it is too much viscosity, we go for a diaphragm type. I mean, the what do you call them? Capillary type, right? Yeah, we don't go for this impulse line. So that is the point. Okay. Then again, one more point. How about this density? Density measurement using uh, differential pressure transmitter. A differential pressure transmitter can be used to measure density. No doubt in that. How? By measuring the difference, pressure difference over a known height in the fluid column. So that is the point. By measuring the pressure difference over a known height in the fluid column. So the density can be calculated from the measured pressure difference by multiplied by the height and the acceleration due to gravity. So these are the things. Then what is this repeatability? Have you heard about the repeatability? Importance of repeatability? Yes. So repeatability in a differential transmitter, pressure transmitter is the ability of the transmitter to provide them same output for the same input pressure over multiple cycles. Okay, that is the point. Okay, you got it? Same output for the same input pressure over multiple cycles. So high repeatability improves the consistency and reliability of the transmitter and reduces the need for frequent calibration. That's it, friends. Good to go. Then we have a capacitive differential pressure transmitter, right? Basically, how it works actually. A capacitive differential pressure transmitter works by measuring the change in capacitance caused by the movement of a diaphragm due to the pressure difference. So the capacitance is typically measured with an electronic circuit and converted into an output signal proportional to the pressure. That's it. There is not much of a rocket science in this. Yeah, thank you. Yeah, see you in the next video. Bye bye. Take care.